Okay, it has been a very long time since we have done a video in my class, so hopefully you're okay with this and it doesn't bother you, because I know at the beginning of the year you kind of liked it, so hopefully you still feel the same way. Okay, we are getting into translating systems of equations. We did all kinds of things with systems of equations before Christmas break: substitution, bread meat bread, elimination, graphing. And then when you came back from break, I showed you how to solve systems with the calculator by graphing them and then also by using matrices. So right now we're going to try to set up some equations from some word situations. But before we get into those word situations, we need to talk about words. Okay, so translating. What does that mean? This means that you're going to try to read something and figure out exactly what it's saying. So we have some keywords here for adding, subtracting, multiplying, and dividing. And I am just going to display these, and I'm going to give you a few moments to write them down. So let's start with adding. These are some words that mean to add. We have plus, sum, total, added to, increased by. These are some of the words that mean add. Okay, these are some of the words that mean to subtract. Difference, decreased by, fewer than, less than. These are some of the words that mean to multiply. Multiplied by, product, times, twice. I know a lot of my students in the past have had issues with that word twice. It means to take something times 2. Sometimes my students think that it means to square something, but it means to multiply something by 2. Okay, and then a couple words that mean to divide. We have divided by and quotient. Okay. Hopefully I have given you enough time to write those words down. If I haven't, you can always pause me for a moment and write them down, and then we can continue on. Okay, getting back into this. Earlier in the year, we came across some words that I called switch words. Do you remember what those were? More than, less than, subtracted from. Those were the 3 that I really focused on in my class. More than, less than, subtracted from. More than is one that you would use when you're talking about adding. Less than is one that you would use when you're talking about subtracting. Subtracted from is another one that you would use when you're talking about subtracting. So these were the 3 I focused in on earlier in the year when we were talking about our switch words. More than, less than, subtracted from. But we do have some others. Another one in the adding category could be added to. So for example, if I said I added 6 to x, I added 6 to x, that would be x plus 6. The 6 got added to the x, so that would be a switch word. And then it's these than words that really get you. So another one that we could use for subtracting is fewer than. If you see these than words, those are going to be switch words. So like I said, my little phrase that I had at the beginning of the year when we were talking about this was more than, less than, subtracted from. But we also have added to and fewer than. Okay, so let's practice translating these sentences down here, and we will be cautious to see if we have any switch words in the sentences. So number 1 says 45 is. Okay, when I see the word 45, I write the number 45. When I see the word is, I put an equal sign. When I read the second part of the sentence, it says 7 times a number increased by 12. Do you see any switch words in there? No. So I'm basically just going to write as I read. How would you write 7 times a number? 7n, 7x, whatever letter you want to use. Increased by. What symbol would we use for increased by? Plus, and it's increased by 12. So if there's no switch words, we basically can just write as we read. Okay, number 2. 14 subtracted from twice a number is 14. Do you see any switch words in here? Yes, we do. We see the switch word subtracted from. So I'm going to start with the back part of the sentence, but before I get to the is. So how could I write twice a number? 2n or 2x. And then what does our switch word subtracted from mean? Subtract. And then I come back to the front of the sentence, 14. So this is how you write 14 subtracted from twice a number. The 14 is being taken from the twice the number. And then I just finish it off with my is equals 14. So this is translating a sentence into algebraic symbols. Okay, let's look at 3. The length of a rectangle is 6 less than twice the width. Do you see any switch words in this? Yes, less than. More than, less than, subtracted from. Okay, so let's start with the back of the sentence. Twice the width. How could we write twice the width? 2x, 2w. What does the switch word less than mean? Subtract. And then come to the first part, which is a 6. Now, this is just how I write 6 less than twice the length. 6 less than twice, 6 less than twice the width. So 6 less than twice the width. And that's what the length of a rectangle is. Okay, this I'm going to write a little differently here. So the length of a rectangle is. So length of the rectangle I'm going to have be represented by an L. The is going to be represented by an equals. And right here where it said 6 less than twice the width, this X right here is representing the width. So if you like it better using a W here, we could do that. So this is how I can write the length of a rectangle is 6 less than twice the width. This one was a little different than the other two because we had 2 different variables in here to talk about. We had one variable to talk about for length and one variable to talk about for width. Okay, let's keep on moving on. Okay, we are not actually going to solve these. I'm going to talk about how you would solve them, but we're not actually going to solve them. So first we want to translate, and then we're going to talk about which method we would use to solve the system. Substitution, bread meat bread, elimination, graphing, our calculator methods that we just learned about. So number 1 says, there are 22 students in a classroom, and there are 12 more girls than boys. Write a system of equations that could be used to find the number of boys, B, and the number of girls, G, in the class. Okay, so the variables we're going to use are B for boys and G for girls. You could always use X and Y or whatever letter you like. But most of the time, if I'm doing a problem like this, I like to use letters that represent words in the actual problem. Okay, so the first thing we're told is that there are 22 students in a classroom. That's the total number of students in the classroom. There's 22 students. So that's your boys and your girls. So one equation we can write for that is the boys and the girls added together make up 22 total students. It says there's 22 students in a classroom, so this is our total equation. The boys plus the girls make 22. Okay, this next one says there are 12 more girls than boys. There are 12 more girls than boys. This one's a little trickier. Who do we have more of? Do we have more boys or do we have more girls? Who do we have more of? We have more girls. Okay, so I'm going to start with G equals because we have more girls. And how many more girls do we have? We have 12 more girls than boys. So the girl amount that we have is the number of boys plus 12 on top of that. So this one's a little trickier. The number of girls in the class is 12 more than the number of boys. Okay, so here is our system of equations, and then we're just going to talk about how we could solve it. If you were to do this by hand, substitution would be the best way to do it. That's our bread meat bread. And the reason is because we have an isolated variable. We have a variable by itself, and then we can plug in its expression into the other equation. If I were to do this how I showed you yesterday, by setting up matrices, then I would want to have the B and the G both on the left-hand side. So let's just talk about how we would do that. So my first equation is good to go. I've got the B and the G both on the left-hand side. My second equation, though, I need to get that B over to the other side. How could I do that? I could subtract the B from both sides. That way B minus B makes 0, and it's gone. So the B would come first, so you can see it's a minus B, or a negative B, and then this G is a positive G, so I can put plus G, and then the equals, and then the only thing left on the right-hand side is the 12. And this is how I could enter it into the calculator if I want to use matrices to solve, which I think most of you will probably like to do it that way. Okay, number 2. A rectangle is 12 feet longer than it is wide. Its perimeter is 76 feet. Write the system of equations that could be used to find the length L and the width W. Okay, so we're going to use L for our length, and we're going to use W for our width. Now let's see if we can try to write these equations. Of course, this is the hardest part. So it says a rectangle is 12 feet longer than it is wide. A rectangle is 12 feet longer than it is wide. Which one do we have more of? Do we have more length or do we have more width? A rectangle is 12 feet longer than it is wide. We have more length, right? Because it's 12 feet longer. So I'm going to start with L equals, that's because we have more length, and it says that it's 12 feet longer than it is wide. So the length is 12 more than the width, 12 more than the width, and that would be W plus 12. So we know that it's 12 feet longer than it is wide. So the length is 12 more than the width. That one's always a little tricky. Our other equation is going to come from the fact that we know its perimeter is 76 feet. So perimeter is the distance around all sides, and we have a special formula for perimeter of a rectangle, and that is 2 times the length plus 2 times the width equals whatever the perimeter is, and we're told that the perimeter is 76. And there are our 2 equations. That's our system. If I were to solve this by hand, I would use substitution. Bread meat bread. And that's because I have an isolated variable. I have an L already by itself, and then I could take this W plus 12 and plug it into that L right there in the bread meat bread process. However, if I were to do this by matrices, I would want the L and the W both on the left-hand side, like it is in the second equation. So the second equation is good, just the way it is when you're using matrices. But if I wanted to get this top equation ready for the matrices, I need to get the W to the other side. Well, since it's a positive W, I would have to subtract it from both sides. And if I did that, I want the L first and then the W. So what kind of L is it? It's a positive L. What kind of W is it? It's a minus W. And what number am I left with? A 12. And now it's ready for matrices. Okay. Let's keep on going. Sean's grandmother gives him 42 coins. Some are dimes and some are nickels. Their total value is $3. Write the system of equations that could be used to find how many nickels N and dimes D Sean's grandmother gave him. So my variables are going to be N for nickels and D for dimes. Okay, this one's a little different than the last couple that we've done. In this first sentence, I'm told that she gives him 42 coins. So she gives him coins that are made up of nickels and dimes. So this is the total number of coins she gives him. So the number of nickels she gave him plus the number of dimes she gave him makes up 42 total coins. This is our total number of coins equation. So many nickels, so many dimes, 42 total. Okay, then it says that their total value is $3. So I need a money equation. This is the one that tricks people. So how much are nickels worth? 5 cents. So that's 0.05 for every nickel, plus how much are dimes worth? 10 cents. So that's 0.10 cents for every dime. And how much money? $3. This is our money equation. And of course I can make that 3.00. So this one right here is our total number of coins equation. And this right here is our money equation, where we talk about how much the nickels are worth, how much the dimes are worth, how much total money. Money, money, money. Okay, if I were to have to solve this by hand, I would do elimination. And that is because I don't have an isolated variable. But if I want to use the calculator, I could solve it with matrices, and you'll notice it's already ready. It's got the N and D on the left-hand side of both equations. So if I were in class and I had my calculator, I would solve by matrices. Okay, and then the last one on our page. The number of grocery items on 2 grocery lists differs by 7. The combined total of the items on both grocery lists is 33. Write the system of equations that could be used to find out how many items are on the first grocery list, L. I cannot read this. I am so sorry. Are on the first grocery list, X, and the second grocery list, Y. Okay, our variables are going to be X, and X is talking about the first grocery list. So first grocery list. And Y is representing the second grocery list. Okay, first sentence, we're told that the number of grocery items on 2 grocery lists differs by 7. What does the word differ mean? It means difference. It means to subtract. So if the number of items on 2 grocery lists differs by 7, that means I'm going to subtract and I'm going to get a total of 7. So however many items I have on one of the grocery lists, subtract how many items you have on the other grocery list, that makes up 7. Okay, and then the second sentence says the combined total of the items on both grocery lists is 33. So the combined total of the items on both grocery lists, this is together, this is the total. So I take how much I have on the first grocery list, I add it to how much I have on the second grocery list, and that makes a total of 33. Is this ready for matrices? Yes. The x and y are both on the left-hand side of both equations, so that's how I would do it. Now, of course, if I were to do this by hand, I would do elimination, and I could do this really easily by elimination, just the way the equations look right now, and that's because my y's have same number in front, opposite signs, so I could put my plus sign and add, and I'd have my answer in moments. But we could also definitely use matrices. All right, thank you so much. Smiley face.